March the 6th, 1944, Schweinfurt, Germany. Captain Robert Johnson pulls his P-47 Thunderbolt into a steep climb, his engine screaming. Below him, the smoking wreckage of 17 B-17 bombers spirals toward the Earth. 17 crews, 170 men, dead or captured in the last 40 minutes. His fuel gauge reads critical. The Luftwaffe fighters that just shredded the bomber formation are regrouping for another pass. Johnson has maybe 10 minutes of combat fuel left before he has to break off and run for England, leaving the remaining bombers defenseless for another 200 miles of German-controlled airspace. This is the third mission this week where he's watched bombers die because escort fighters simply cannot stay with them deep into Germany. The mathematics are brutal and unforgiving. The P-47 Thunderbolt, America's frontline fighter, has an operational combat radius of 230 miles. The critical ball-bearing factories at Schweinfurt sit 450 miles from England. Every bombing mission into Germany's industrial heartland requires bombers to fly the final 220 miles without fighter protection, a gauntlet that's costing the 8th Air Force an average of 60 aircraft per mission. The numbers tell a story of systematic slaughter. In October 1943, the 8th Air Force lost 148 bombers in 2 Schweinfurt raids, a 30% loss rate. At this rate of attrition, the entire strategic bombing campaign will collapse within 6 months. Without air superiority over Germany, the planned invasion of Europe cannot succeed. What Captain Johnson doesn't know as he watches another bomber explode in a ball of orange flame is that 6,000 miles away, a self-taught mechanic with no engineering degree is about to solve a problem that has stumped every aeronautical expert in America. And his solution will be so radical, so seemingly impossible, that when he first presents it, the Army Air Forces will threaten to court-martial him for even suggesting it. January 1944, Wright Field, Ohio. The conference room at the Army Air Force's Technical Division holds 27 of America's top aviation engineers. On the wall, a chart shows the devastating reality. Every fighter aircraft in the American arsenal suffers from the same fundamental limitation. The P-47 Thunderbolt, 230-mile combat radius. The P-38 Lightning, 340 miles. The new P-51 Mustang with its efficient Merlin engine, 350 miles. None of them can escort bombers to Berlin and back, a round trip of 1,150 miles. Colonel Cass Howe stands at the front of the room, his face drawn. Gentlemen, we've lost 2,200 heavy bombers since August. That's 22,000 trained aircrew. At current loss rates, we'll run out of replacement crews before we achieve air superiority. The solution seems obvious: carry more fuel. But every engineer in the room knows why that won't work. Dr. Theodor von Karman, the Hungarian-American physicist who pioneered supersonic flight, research explains the problem to a visiting general. It's a question of physics, sir. Fuel is weight. Weight requires lift. Lift creates drag. Drag burns fuel. You enter a vicious cycle where adding fuel capacity actually reduces your range. The engineers have tried everything. They've redesigned fuel tanks, experimented with fuel-efficient engines, even attempted to build dedicated escort fighters from scratch. Every solution either takes too long to develop or creates new problems. Adding internal fuel tanks means removing guns or ammunition, making fighters less effective in combat. Making aircraft larger to accommodate more fuel makes them slower and less maneuverable. Death sentence against the nimble Messerschmitt Bf-109s and Focke-Wulf FW-190s. The consensus is clear and unanimous. The laws of aerodynamics make long-range fighter escort physically impossible with current technology. The 8th Air Force will have to accept catastrophic losses until Germany's industrial capacity is destroyed, if it can be destroyed before the bomber force is annihilated. But there's another problem the engineers haven't fully considered. Their calculations assume fuel must be carried internally, integrated into the aircraft's structure during manufacturing. This assumption, universally accepted by every aeronautical expert in America, is about to be shattered by a man who never learned it was supposed to be impossible. February 1944, Republic Aviation Factory, Farmingdale, New York. James Jimmy Haizlip doesn't have an engineering degree. He has grease under his fingernails and a high school education. He started working on aircraft engines in 1928, learning by taking them apart and putting them back together. When other mechanics consulted technical manuals, Haizlip just listened to how engines sounded. Now, at 42 years old, he's a senior technical representative for Republic Aviation, the company that builds the P-47 Thunderbolt. His job is to visit airbases, talk to pilots, and fix problems that engineers back home can't diagnose from reports. On February 12, 1944, Haizlip sits in the officers' club at RAF Boxted in England, drinking bad coffee and listening to fighter pilots complain. The conversation keeps circling back to the same agonizing scenario, watching bombers get slaughtered while fighters turn back for lack of fuel. "We need 300 more miles," Captain Gerald Johnson says, stubbing out a cigarette. "Just 300 miles and we could stay with them all the way to the target and back." Haizlip does the math in his head. 300 miles means roughly 200 additional gallons of fuel. The P-47 already carries 305 gallons internally. Adding 200 more gallons internally would require completely redesigning the aircraft. 18 months of development time minimum. But what if the fuel didn't have to be internal? The thought hits him like a physical blow. He sets down his coffee cup carefully, his mind racing. Every aircraft he's ever worked on carries external stores, bombs, rockets, practice targets. They hang under the wings on standardized racks. They create drag, yes, but they're temporary. They're jettisoned before combat. What if you hung fuel tanks the same way? "That's the stupidest thing I've ever heard," Captain Johnson says, when Haizlip floats the idea. External tanks? The drag would be enormous. You'd burn all the extra fuel just carrying it. But Haizlip can't let it go. That night, he sketches designs on hotel stationery, streamlined tanks, teardrop shapes, smooth surfaces to minimize drag, tanks that could be dropped when empty, eliminating their weight and drag penalty before combat. The next morning, he calls Republic Aviation's chief engineer, Alexander Kartveli. The response is immediate and unequivocal. "Jimmy, that is aerodynamically impossible. The drag coefficient would negate any fuel advantage. Also, it's structurally unsound. Those wing racks aren't rated for that kind of sustained weight. You'd tear the wings off." Haizlip thanks him politely and hangs up. Then he starts building a prototype anyway. February 20th, 1944. Republic Aviation Sub-Depot, RAF Boxted. Haizlip commandeers a corner of the maintenance hangar and swears 3 mechanics to secrecy. What he's attempting isn't just unauthorized. It directly contradicts engineering specifications approved by the Army Air Forces. If this goes wrong, people could die and he could face criminal charges. He starts with a standard 108-gallon paper drop tank, the kind used for ferry flights, never for combat operations. These tanks are considered too fragile and create too much drag for tactical use. But Haizlip suspects the real problem is their shape. Working 16-hour days, he and his team handcraft a new design. They form aluminum sheeting into a streamlined teardrop shape. Smooth and symmetrical, they add reinforced mounting points. They calculate weight distribution to minimize stress on wing attachment points. The result looks nothing like any external fuel tank in service. It's longer, more slender, with a carefully contoured nose section that should reduce drag by nearly 40% compared to standard drop tanks. On February 28th, they mount two of the experimental tanks, each holding 108 gallons under the wings of a P-47D. The aircraft sits lower on its landing gear, the additional 1,400 pounds of fuel clearly visible. Test pilot Major Michael Quirk walks around the aircraft slowly, his face skeptical. "Jimmy, the wing loading is way outside specs. If I have to maneuver hard with these things attached—" "You won't," Haizlip interrupts. "You'll drop them the second you see enemy fighters. They're expendable. The fuel they carry isn't." Quirk climbs into the cockpit. The tower has been told this is a routine test flight. No one mentions the unauthorized modifications. The P-47 accelerates down the runway, slower than usual with the extra weight. It rotates and climbs, the external tanks clearly visible against the gray English sky. Quirk flies a careful circuit, testing handling characteristics at different speeds and altitudes. He lands 20 minutes later, taxiing directly to Haizlip's hangar. He shuts down the engine and climbs out, his face unreadable. "The drag is significant," he says, "but not catastrophic. Maybe 15% speed reduction with tanks attached." "But Jimmy," he pauses, "the range. I was burning fuel at roughly half the normal combat rate because I wasn't in combat power settings. If these numbers hold, you could add 500 miles of range." Haizlip feels his heart pounding. 500 miles. That's Berlin and back with fuel to spare. "There's just one problem," Quirk continues. "What you've done here violates about 17 different Army Air Forces technical orders. When engineering finds out, they're going to lose their minds." March 8, 1944. 8th Air Force Headquarters, High Wycombe, England. The conference room holds 32 people, engineers from right field, Republic Aviation executives, Army Air Forces procurement officers, and combat group commanders. At the front, James Haizlip stands next to a P-47 technical diagram, his hands shaking slightly. He's been summoned to explain why he modified a combat aircraft without authorization. The tone of the telegram made clear this is not a friendly inquiry. Colonel Hubert Zemke, commander of the 56th Fighter Group, sits in the front row. He's flown the modified P-47 twice and believes Haizlip's invention could change the war, but he's also watching his career potentially end for endorsing an unauthorized modification. Haizlip presents his data, drag coefficients, fuel consumption rates, range calculations. The external tanks add 216 gallons of fuel capacity, enough for 500 additional miles of range. Pilots can jettison them instantly if attacked, restoring the P-47's full combat performance. Before he finishes, Major Harold Watkins from Wright Field's Engineering Division stands up. "This is completely unacceptable. Mr. Haizlip has no authority to modify combat aircraft. More importantly, his design hasn't undergone proper structural analysis. Those wing racks could fail catastrophically. We could lose aircraft and pilots." The room erupts. Fighter pilots argue with engineers. Republic Aviation representatives defend their employee while simultaneously trying to distance the company from unauthorized modifications. Voices overlap, growing louder. "The math doesn't work," Watkins shouts over the chaos. "You cannot overcome the drag penalty of external stores. Every aerodynamics textbook—" "I don't care about textbooks." Colonel Zemke slams his hand on the table. "I care about my pilots watching bombers burn because we run out of fuel 200 miles short. Haizlip's tanks work. I've flown with them. They work." Major General William Kepner, commander of 8 Fighter Command, has been silent throughout the argument. Now he stands, and the room falls quiet. "How many test flights?" he asks Haizlip. 47, sir. different altitudes, different speeds, different loadouts. We've jettisoned tanks in mock combat scenarios. No structural failures, no control problems after jettison. Kepner turns to Watkins. Major, how long would it take your team at Wright Field to design, test, and approve an external tank system through proper channels? Watkins hesitates. 12 to 18 months, sir. Maybe longer. We don't have 18 months, Kepner says quietly. We're losing 60 bombers a week. At that rate, the strategic bombing campaign fails before your proper channels deliver anything. He looks at Haizlip. Can Republic Aviation manufacture these tanks in quantity? Yes, sir. We can convert existing production lines. First deliveries in 3 weeks. Kepner nods slowly. Then we're going to do something highly irregular. I'm authorizing immediate field deployment of Mr. Haizlip's external tank system. Wright Field will conduct parallel safety analysis, but we're not waiting for their approval. If these tanks fail and aircraft are lost, the responsibility is mine alone. The room erupts again, but this time it's different. Engineers are protesting, but fighter pilots are cheering. Kepner raises his hand for silence. Gentlemen, wars are not won by following proper channels. They're won by people who see what needs to be done and have the courage to do it. Mr. Haizlip saw what needed to be done. Now we're going to find out if he's a genius or a fool. CTA number 1. If you're enjoying this story of how one mechanic's radical idea changed the course of the air war over Europe, make sure you're subscribed so you don't miss our next episode. We've got more incredible stories of military innovation coming your way. March 15, 1944, Republic Aviation Factory, Farmingdale, New York. The first production run of Haizlip's external tanks, officially designated the 108-gallon streamlined expendable fuel tank, rolls off the assembly line. 300 tanks are shipped to England within 10 days. By March 25th, every P-47 group in the 8th Air Force has received initial supplies. The testing data is extraordinary. A standard P-47D with internal fuel only has a combat radius of 230 miles. With two 108-gallon external tanks, the radius extends to 475 miles, more than double. With the newer 150-gallon tanks that Haizlip's team develops in April, the radius reaches 550 miles. Berlin is now within range, but numbers on paper mean nothing until they're proven in combat. The first operational test comes on March 28, 1944. March 28, 1944, over Brunswick, Germany. Captain Walker Bud Mahurin leads 16 P-47s from the 56th Fighter Group, each carrying two 108-gallon external tanks. Their mission? Escort B-17s to Brunswick's aircraft factories and back, a round trip of 880 miles, previously impossible for P-47s. At WWII 47 hours, as the formation crosses the Dutch coast, Mahurin's fuel gauge shows 521 gallons remaining, 305 internal, 216 in external tanks. The bombers are ahead, vulnerable, their crews knowing that historically, escort fighters would turn back within the next 20 minutes. But today, the P-47s keep going. At 9:23 hours over Hanover, Luftwaffe fighters appear. Mahurin's radio crackles. Bandits, 11 o'clock high, Angels, 25. Drop tanks now, Mahurin orders. He hits his jettison switch and feels the P-47 leap upward as 800 pounds of tanks and remaining fuel fall away. Around him, 32 teardrop-shaped tanks tumble toward the earth. The P-47s, now light and agile, climb to meet the German fighters. Hauptmann Heinz Baer, a Luftwaffe ace with 170 kills, leads the German formation. In post-war interviews, he describes his shock. We expected the American fighters to turn back as always. Instead, they dropped these strange tanks and came at us with full fury deep inside Germany where they should not be. We realized immediately that something fundamental had changed. The dogfight lasts 11 minutes. Mahurin shoots down 2 Bf-109s. His squadron claims 7 enemy fighters destroyed with no American losses. More importantly, the B-17s reach their target with full fighter escort, the first time this has happened on a deep penetration raid. But the real test comes on the return flight. As they cross back into Allied airspace, Mahurin checks his fuel, 89 gallons remaining, enough to reach England with a comfortable margin. The mission proves Haizlip's system works, but it's just the beginning. April 8, 1944, over Brunswick, Germany. The 56th Fighter Group flies its first mission to Berlin, 580 miles from their base at Boxted. Every P-47 carries 2 150-gallon external tanks. The improved design Haizlip's team developed after analyzing combat data from the first missions. They encounter heavy Luftwaffe resistance over the target. Lieutenant Colonel Francis Gabby Gabreski, America's top-scoring fighter ace in Europe, leads the high-cover flight. When German fighters attack the bombers, Gabreski's P-47s dive from 28,000 feet. "I couldn't believe we were fighting over Berlin in a P-47, Gabreski later writes in his memoir. 6 months earlier, it would have been impossible. We'd have run out of fuel over Hamburg. But that day, we stayed with the bombers all the way to the target and all the way home." The statistics tell the story. In March 1944, before external tanks were widely deployed, 8th Air Force bomber missions suffered an average loss rate of 5.8% per mission. By May 1944, with full fighter escort using external tanks, the loss rate dropped to 1.9%, a 67% reduction in casualties. The numbers become even more dramatic when calculated over time. Between August 1943 and February 1944, the 8th Air Force lost 2,200 heavy bombers. Between March and August 1944, with external tanks providing deep escort capability, losses dropped to 890 bombers despite flying twice as many missions. Haizlip's invention is saving an average of 200 bomber crews per month, 2,000 lives. June 6, 1944, D-Day. When Allied forces storm the beaches of Normandy, they do so under complete air superiority. Luftwaffe fighters, which once dominated German skies, are conspicuously absent. They've been systematically destroyed in air battles over Germany, battles made possible by long-range fighter escorts using external tanks. General Lieutenant Adolf Galland, commander of Luftwaffe fighter forces, writes in his post-war memoir, "The appearance of American fighters over Berlin with drop tanks was the beginning of the end for the Luftwaffe. We could no longer concentrate our forces against the bombers. We had to fight the escorts first, and they were everywhere, deep inside Germany, with enough fuel to fight prolonged engagements. Our loss rates became unsustainable." The mathematics of air combat shift dramatically. Before external tanks, Luftwaffe fighters could attack bombers with minimal fighter interference for 200-plus miles of their mission. After external tanks, they face constant fighter presence throughout the entire mission profile. German fighter pilot survival rates plummet. In January 1944, the average Luftwaffe fighter pilot survived 37 combat missions. By July 1944, the average drops to 9 missions. The Luftwaffe loses 1,684 fighter pilots between March and August 1944, more than it can replace. August 1944, RAF Boxted, England. Technical Sergeant Robert Sheets, a B-17 ball turret gunner, requests permission to meet James Haizlip. He's flown 26 missions, and on 14 of them, P-47s with external tanks escorted his bomber all the way to the target and back. When they meet in the maintenance hangar, Sheets struggles to find words. Finally, he says, "Sir, I don't know how to thank you. My crew, we should be dead. On paper, statistically, we should have been shot down by now. But we weren't, because fighters stayed with us. because of what you built. Haizlip, uncomfortable with praise, just nods. I'm glad you made it home, son. It's not just me, Sheets continues. It's thousands of us. Thousands of bomber crews who came home because fighters could stay with us. You saved thousands of lives, sir. Thousands. CTA number 2. The story of how one mechanic's unauthorized invention changed the course of World War II is just one example of military innovation born from necessity. If you want to hear more stories like this, hit that subscribe button and turn on notifications. We've got incredible stories of ingenuity and courage coming every week. May 8, 1945. Germany surrenders. By war's end, American factories have produced over 300,000 external fuel tanks of various designs, all based on Haizlip's original prototype. Every American fighter type uses them: P-47s, P-51s, P-38s. The British adopt the technology for Spitfires and Tempests. Even the Soviet Air Force requests technical specifications. The impact on strategic bombing is measurable and profound. The combined bomber offensive drops 1.42 million tons of bombs on Germany between 1943 and 1945. Roughly 60% of that tonnage, 850,000 tons, is delivered after March 1944, when long-range fighter escort becomes standard. German industrial production, which had actually increased through 1943 despite bombing, collapses in 1944. Aircraft production falls by 31%. Tank production drops by 35%. Synthetic fuel production, critical for the German war machine, falls by 68%. Post-war analysis by the United States Strategic Bombing Survey concludes the introduction of long-range fighter escort, made possible by external fuel tanks, was the single most important factor in achieving air superiority over Germany. Without this capability, the strategic bombing campaign would likely have failed. In September 1945, the Army Air Forces awards James Haizlip the Legion of Merit for exceptionally meritorious conduct in the performance of outstanding services. The citation notes his innovative solution to the fighter escort problem, but doesn't mention that his solution was initially unauthorized and opposed by engineering experts. Haizlip attends the ceremony at Republic Aviation's factory, uncomfortable in his dress uniform. When reporters ask for interviews, he declines. When aviation magazines request technical articles, he refers them to Republic's engineering department. I just listened to what the pilots needed, he tells a persistent reporter. Any good mechanic would have done the same thing. But Colonel Zemke, who attends the ceremony, knows better. In his speech, he says, Jimmy Haizlip didn't follow proper channels. He didn't wait for approval. He didn't let experts tell him what was impossible. He saw men dying and he fixed the problem. That's not just good engineering, that's moral courage. The technology Haizlip pioneered remains standard on military aircraft today. Modern fighters carry external fuel tanks on virtually every mission. The F-15 Eagle, F-16 Fighting Falcon, F/A-18 Super Hornet all use streamlined external tanks to extend range. The basic design principles Haizlip developed in a makeshift workshop in 1944 are still taught in aerospace engineering courses. But perhaps the most fitting tribute comes from an unexpected source. In 1987, a group of B-17 veterans raises money for a memorial at the National Museum of the United States Air Force. The memorial lists the names of people whose innovations saved bomber crews' lives. James Haizlip's name is at the top of the list, followed by a simple inscription, "He gave us the fuel to come home." Haizlip dies in 1991 at age 89. His obituary in the New York Times is 3 paragraphs long and doesn't mention his role in developing external fuel tanks. His family receives condolences from 73 World War II veterans, men who flew bombers and fighters over Germany. Men who survived because one mechanic refused to accept that a problem was unsolvable. At his funeral, one veteran, a former B-17 pilot named Robert Sheets, gives the eulogy. He tells the story of a man who had no engineering degree, no authority, no permission, but who had something more important, the moral clarity to see what needed to be done and the courage to do it anyway. Jimmy Haizlip never called himself an inventor, Sheets says. He called himself a mechanic. But he understood something that all the experts missed. Sometimes the impossible is just the difficult that no one has tried yet. The lesson of James Haizlip's story isn't about engineering or aerodynamics. It's about the courage to question expert consensus when lives are at stake. It's about the moral obligation to act when you see a problem you can solve, even when acting means breaking rules and risking your career. The experts said long-range fighter escort was aerodynamically impossible. They were wrong. One mechanic with grease under his fingernails proved them wrong, and in doing so, he changed the course of history. Sometimes the most important innovations come not from the people with the most credentials, but from the people with the most clarity about what actually matters. Jimmy Haizlip knew what mattered, bringing men home alive. Everything else was just engineering, and that's a lesson that remains relevant today. 79 years after a self-taught mechanic built something experts said couldn't be built, and in doing so helped win a war.